Okay, so first I'm going to do number 2, which is the hardest one. And number 2 is y times the quantity of the ln of x minus the ln of y dx equals x ln of x minus x ln of y minus y, all of that times dy. So the first thing that you have to do for this problem is you're going to have to change the ln of y and the ln of x's to the ln of x over y. And in doing that, we're going to use the property that is, if I have the ln of a over b, that's equal to the ln of a minus the ln of b. So, in using this property, we can say that this is y times the ln of x over y dx equals, we're going to factor out the x over here, so we can just have the same thing over here, ln of x minus ln of y. So when we factor out the x, we get x times the ln of x over y minus y dy. Okay, from this step, now we're going to want to choose either u or v. And we're going to pick v in this situation because v is equal to x over y. And we have x over y in our ln's. So it's going to be easy to just place a v in there. So we're going to say v equals x over y. And if v equals x over y, then x is going to equal v times y. And dx is going to equal v dy plus y dv because of the chain rule, which is the first times the derivative of the second plus the second times the derivative of the first. So knowing all this information, we can plug it in and it'll be y times the ln of v times dx is going to change into this, so it's going to be v dy plus y dv equals x times, x is equal to v y, so it's vy times the ln of v minus y dy. Notice that all the y's in here are staying the same because when we're using v, we only substitute for x, but when we're using u, we substitute for y. So from that step, we go on to simplify this even more. So what we want is this. We're treating this as its own term. We want this to be multiplied by this plus this times this. Kind of like if I had 2 times 2x plus y, I'd want to multiply the 2 times 2x to get 4x, and I'd want to multiply the 2 times y to get 2y. In this same way, we have to multiply this by this plus this times this. So from here we're going to end up with y v times the ln of v times dy, because we multiply this together. And then we're going to do plus y squared times the ln of v times dv. because we multiplied this and this. So then it's going to go on to be, well, looking at this over here, we don't really need to simplify much, but we see that we have a v in both, a y in both terms, so we could take out that y. So it could be equal to y times v ln of v minus 1. And of course, all of that is still multiplied by dy. Sorry, that looks like a 6. Okay, so from this step, we have it pretty simplified, but we still want all of our dy's on one side and all of our dv's on one side. Why? Because when we integrate, we want to integrate to respect to, we want to integrate with respect to y on the one side and with respect to v on the other side. So we're going to take this dy and we're going to move this over here. In order to do that, we have to subtract it from both sides. So that crosses out, and we have to, let me make that darker, subtract it from this side also. Okay, and so this is how far we've gotten on this part. It's going to be y squared times the ln of v dv equals y times v ln v minus 1 dy minus yv ln v dy. Okay, now that we have this, we are going to want to do something on this side, because this side is the side where we need to just get 1 dy. So basically, let's see what we can factor out. We're treating these like they're two separate terms. So we have this and we have this. What can we pull out from this and this? Well, we see that they both have a y and they both have a dy. So we're going to say y dy, because that's what we took out. That looks crooked. And then whatever's left over, we're going to put v ln of v minus 1. And in here, what's left over is v ln of v. So we're going to say minus v ln of v. Now from here, once we write this, let's just bring this down. We realize that, look, we can cross that out. And now that we see that we can cross this out, it becomes way simpler. So now we have this. All that just times -1. So we see is that we still need our y's on one side and our v's on the other side. So we're gonna, hey, let's first, we could move this -1 over here, but we don't have to. You just make it -y dy. So basically, at this point, we want our y's on one side, so we want to get rid of the y over here. So we divide both sides by y squared. We end up with ln of v dv equals -1 over y dy. Then we can integrate. Now that we have all our y's and dy's on one side and our v's and dv's on the other side. When we integrate, this side's really easy to integrate, so we're going to go ahead and integrate that first. And okay, well, over here you can see that this is the negative integral of 1 over y. And if the integral of 1 over x, when it's respect to x is ln of x, then this is just going to be ln of y. So I'm going to say this is negative ln of y plus c. And we're going to call this c2 because over here, the c, we're going to make it c1. So this can be integrated by, I'm not sure what you call the rule, but it's when you make one of them your f of x and you make the other your g prime of x. Not sure if you can see that or if it's too confusing, but I'll start this problem over again. Okay, so we've got to this part so far where we have negative ln of y plus c on this side. Well, I forgot to put the absolute value in because when you integrate, your ln of x or your ln of y will always be absolute value. So we're dealing with over here where we have to have an f of x and we have to have a g prime of x. And so we're going to make our, well, looking at this, you don't really see a f of x or you don't see a g prime of x because you only see one function, right? Well, we're going to make our g prime of x 1 because 1 times ln of v is still ln of v. So it's going to be in this form. Okay, so now we need, well, since we have our f of x and our g prime of x, well, let's write this out. Our f of x is going to be the ln of v, and that means our g prime of x is going to be what? 1 over v, right? And we have our g prime of x, which is 1, so that means our g of x is going to be, well, we shouldn't use x's, we should use v's, right? That means our g of v is going to be v. Okay, so the rule says that the integral of f of x times g prime of x is going to be f of x times g of x minus the integral of f prime of x g of x with respect to x. But in this case, of course, it'd be f of v times g of v minus f prime of v times, well, minus the integral of f prime of v times g of v with respect to v, which is dv. So basically, looking at this, we can just plug it in. We can say now the derivative is going to be v times ln of v minus the integral of 1 over v times v dv. And if we multiply these, it's just going to be 1 because they cross out. So it's basically just dv. And dv, the integral of dv is going to be what? Just v. So the integral of ln, of ln of v is altogether going to be v ln of v minus v. So previously we got our result, which was v ln of v minus v plus c1 equals negative ln of the absolute value y plus c2. And now you see why we made this one c2, because this one was c1. So now we want to get everything on the side it's supposed to be. So what we're going to do is we're going to move this over to this side. So we want everything on the same side. We're going to add ln of the absolute value of y to both sides. And we're going to get v ln of v minus v plus the ln of absolute value of y plus c1 equals c2. Now we want our c's on the same side also. So we're going to do is we're going to subtract C1 from both sides. So I want to get rid of it over here. So once we do that, we get ln of v minus v plus ln of the absolute value of y equals c. And remember, at the bottom somewhere, you're going to say where c is equal to c2 minus c1. Okay, now even though this is we're basically done, you have to put in the v's where they need to be. So so now that we've gotten this, and we're pretty much almost done, we still have to remember that in the beginning we made v equal x over y. So now every time we see a v, we have to put an x over y. Okay, for number 2, the final answer is this, because you've replaced your v's with x over y. And remember that the y does not need to be replaced, because when you're using v, you only replace the x's. When you're using u's, you only replace the y's. Okay, then we're going to go on to number 3. This is our question, number 3. The quantity of 2x plus y plus 1 times y prime equals 1. First thing we're going to want to do is change y prime to dy over dx, just so we can manipulate it better. So it's going to end up being 2x plus y plus 1 times dy over dx equals 1. Now what we're going to use in this problem is u substitution. So we're going to pick this to be u. So u is going to equal 2x plus y plus 1. Now we're going to do du dx. So that means we're taking the derivative with respect to x. So this is just going to be 2. This is going to be dy dx, because derivative of y with respect to x. And then, of course, it's going to be plus 0, or nothing at all. So in this case, since we want to substitute everything in, this is already going to be our u, but we don't want our dy dx there. We want it in terms of u. We want it in terms of u. So what does dy dx equal? Well, if we want to get rid of the 2 on this side and find out what dy dx equals, we have to subtract 2 from both sides. And so we end up with this. Du dx minus 2 equals dy dx. So we can replace that right here. We say du dx minus 2 equals 1. Okay, now we want this simpler. So what we're going to do is we're going to try and get the u on the other side, because we want du dx by itself. So we're going to divide both sides by u. That's going to cross out. It's going to end up being du over dx minus 2 equals 1 over u. And we don't want the 2 over there because we want du dx by itself, so we add 2 to both sides. So du over dx equals this, right? Now we can get a common denominator, and we can make this into 1 over y plus 2u over u. Because u over u is 1. It's not going to change the fact that that's still 2, right? But we still have the common denominator. So then we have du over dx is equal to 2u plus 1 all over u, because we combine them. So this is basically what we have so far. But we want the u's on the other side. And I'll show you why. Okay, so we end up with this right here. and we want to separate the differentials, so we're going to multiply both sides by dx. And so that's going to be times dx. That's going to cancel out those dx's. And then over here we're going to multiply this by dx also. So we're going to have du equals 2u plus 1 over u dx. Now looking at this doesn't really look right because we want the du's on one side and the dx's on one side. I mean the u's on one side and the x's on the other side. And over here we have a combination of u and the dx. So what we're going to have to do is we're going to have to manipulate this in some form or shape. Now, if I have 2/5, I know that I can get rid of it by multiplying it by 5/2 because that's its reciprocal, and they cross out to equal 1. Well, the same thing we can do in this case. So we're going to multiply this by its reciprocal. Whatever we do to one side, we have to do to the other. So we're going to end up with 2u plus 1 over u times u over 2u plus 1, because that's its reciprocal, dx. Whatever you do to one side, you have to do to the other. So it's going to be u over 2u plus 1 du. So from here, we see that we can cancel, right? And we just end up with u over 2u plus 1 du equals dx. And now that we have our u's and x's, we have them on the sides that they're supposed to be on, we can go ahead and integrate. Now, when you're integrating this, we see that they have the same degree. So we can't really do u substitution because if we made that u, our du is going to be 2. And there's a u up there, not just a constant. So we have to do long division. So from this side, we're going to say u, I'm going to say u plus 0. It's going to make it easier. Divided by 2u plus 1. Now, what do I need in order to make the 2u a u? 1/2. Because when I multiply 2u by 1/2, it ends up being u. So we're going to put a 1/2. And then we're going to multiply. And so 1/2 times 2u plus 1 is going to be u plus 1/2. Now we're going to subtract them. So 0 minus 1/2 is going to be negative 1/2. U minus u is just 0. So we have a remainder of minus 1/2 over 2u plus 1. Okay, so we can put this in. We can say that this is equal to 1/2 minus 1/2 over 2u plus 1 equals the integral of dx. And so what happens is we see that we can take out a 1/2, right? And so we can take that out, put it on the outside to make it look simpler. And we have 1 minus 1 over 2u plus 1 equals integral of dx. Okay, now that I have this, I can separate, because the integral of f of x minus a g of x, which is basically just saying one function minus another, is going to be the integral of f of x dx minus the integral of g of x dx. Basically saying we can separate them. So in order to make this simple, we're going to separate them. So we end up having 1/2 on the outside, right? The integral of 1, oh, forgot to put the du right here. We end up having the integral of 1 du which would just be du, right? Minus the integral of 1 over 2u plus 1 du equals the integral of dx. From this point 2 du, we needed 2, right? So that means we're going to have to put a 1/2 on the outside. And if you don't understand that concept, I'll break it down even more. Basically, we're focusing on this part of the problem that says this, right? So, in this problem, we're using substitution. And we're saying that z equals 2u plus 1, then dz is going to equal 2 du. So looking at this, I know I can replace this with 1 over z. And I know that I can replace du with what? We don't know yet. So if I want du by itself over here, I divide both sides by 2. And so I know now that du is dz over 2. And that means now I can take out the 2, because that's the same thing as 1/2 dz. I can take out that 1/2 right there because it's a constant, so that can go on the outside. It could be 1 over z dz. Now, the thing is, if you understand it easier by saying, oh, okay, I have a du over here, and I need a 2 du, that means I have to put 1/2 on the outside. I mean, that's simple also. But if you don't understand it that way, you can think about it this way. And so with this, ends up giving you ln of z. Well, 1/2 ln of z. Why? Because if the integral of 1 over x is ln of x, the integral of 1 over z, because it's respect to z, is going to be the ln of z. And of course, we have that 1/2 constant that just comes up here. So now, knowing all of this, if I replace z with our original value, which z is equal to 2u plus 1, it's going to be 1/2 the ln of 2u plus 1. So let's write that in. So now we know we have 1/2 times u minus 1/2 of ln of 2u plus 1, absolute value of course, equals, well, plus c1 equals x plus c2. Now looking at all of this, it pretty much gets simpler from here. You want to multiply everything out. So basically, we want to get both of our from here we want to simplify, so we want all our c's on one side. So we're going to bring our x over, so we're going to subtract x from both sides. We're going to end up with 1/2 u minus 1/2 the ln of the absolute value of 2u plus 1 minus x plus c1 equals c2. Then once we get that, we want the c's on one side, of course, so 1/2 u minus 1/2 ln of the absolute value of 2u plus 1 minus x equals c, because I'm subtracting c2 minus c1. So once I have that, in your final answer you're going to have to write somewhere where c equals c2 minus c1, like right here. It's going to have to be in your final answer because we're going to change that to C so it can be much simpler. Actually, we're going to change it to C3 because we're going to do some more altering with our C. Okay, so we have this so far. It's kind of simplified, but we have to do more altering. Okay, so and now we're going to kind of look back to our information from before. We knew that our C3 was our C2 minus C1, and we know that U is 2x plus y plus 1 from the beginning of the problem. Now we're going to put in 2x plus y plus 1 every time we see a U. So we're going to have 1/2 times the quantity of 2x plus y plus 1 minus 1/2 ln of absolute value of 2 times 2x plus y plus 1 plus 1 minus x equals C3. We're going to simplify. It's going to be 1/2 times quantity of 2x plus y plus 1 minus 1/2 ln of, now we're going to distribute that too.
Attention all beautiful ladies of Wade Hall. Can Angelia Roberts please come to the lobby? Angelia Roberts, please come to the lobby. Again, Angelia Roberts, please come to the lobby. Thank you.
We're going to distribute that too. So we're going to go 4x plus 2y plus 2 plus 1. Minus x equals C3. We're going to 1/2 times the quantity of 2x plus y plus 1 minus 1/2 ln of 4x plus 2y. And the 2 plus 1 over here is just going to be 3. So it's going to be plus 3. Remember your absolute value sign. Minus x. Now we want to distribute that 1/2 in. So it's going to be 2x plus y plus 1 over 2 minus the ln of 4x plus 2y plus 3. Remember your absolute value sign still. All over 4, because when I multiply that 1/2 by that 1/2, it's going to be 1/4. Minus x equals C3. Now, if we want this to look prettier, we have to find the common denominator, and this is going to help us with the C in the end to find our final C. And so if we want a common denominator, the best looking one is 4 right now. So we're going to multiply this by 2 over 2 to get this one to be 4. And we're going to multiply this by 4 over 4. So in doing that, we get 2 times 2x plus y plus 1, all that over 2, minus, nothing changes with this because its denominator is already 4, minus 4x over 4 because we multiplied this by 4 over 4, equals C3. We can simplify this even more, make this now 4x plus 2y plus 2 over 2. I apologize. This was supposed to be 4 because I multiplied the 2 by 2. Minus the ln of absolute value of 4x plus 2y plus 3, all that over 4, minus 4x over 4 equals C3. Okay, so this is basically what we ended up with so far. And now we have to combine them, have to add them. So we have 4x plus 2y plus 2 minus the ln of 4x plus 2y plus 3 minus 4x, all of that is going to be over 4. It's going to be equal to C3. And now we can see that the 4x is crossed out because this is 4x and this is negative 4x. So now we just have 2y plus 2 minus the ln of the absolute value of 4x plus 2y plus 3. All of that over 4 equals C3. Now, if we want to get rid of that 4, we can multiply 4 on both sides. And that means that these cross out, these 4's. And now we end up with 2y plus 2 minus the ln of the absolute value of 4x plus 2y plus 3 equals 4C3. Now 4C3, that's a constant. So now we can make it 2y plus 2 minus the ln of absolute value of 4x plus 2y plus 3 equals C. And this is going to be our final answer. And remember to add at the end where C3 equaled C2 minus C1, and also where C equals 4C3. And this will be your final answer.